Hello everyone and welcome to MD Tutors. I'm Tsulu and I'll be doing question 1 with you. Let's get right to it. Alright, so it says evaluate the following. So we have 1 plus 2 plus 4 plus 5 plus 7 plus 8 and then plus 10, 11, 13 and then we have 95, 97, 98 and 100. So do we have an arithmetic series or geometric series? Remember, we can't really have a quadratic series. It's not covered in the syllabus. So if I look at the first two terms, I can see that there is a difference of 1. And then between 2 and 4, there's a difference of 2. Between 4 and 5, there's a difference of 1. And between 5 and 7, a difference of 2. So basically, that's 1, that's 2, that's another 1, that's 2, and so forth and so on. So here we can see clearly that we neither have a geometric series or an arithmetic series. But I have noticed something. Okay, so I have realized that here there's missing a 3. And then there I'm missing a 6. There I'm missing a 9. And there I'm missing a 12. Okay, so I basically have whole numbers here without the multiples of 3. So this question is quite similar. If you've watched the arithmetic video, the arithmetic sequence and series video, you'll see that I've covered something similar there. So we have natural numbers here, but the only thing that's missing is the multiples of 3. So my strategy here to evaluate, I'm going to sum up, okay? I'm going to sum up the natural numbers, okay? And then I'm going to subtract the multiples of 3. Because that's the only thing that's missing from this series. All right, so yeah, let us get to it. So if I sum up, and if I do sum up, I'm definitely using the arithmetic sequence formula, or rather series, not sequence, the series formula. Okay, so if I were to, let me just take it up. All right, I would use this formula here. It's n over 2. And because I have my first and last term, I'm going to use this formula instead of the other long one. And my natural numbers, they go from 1 to 100, okay? So if I'm looking for the numbers, the number of terms, that would be 100. Okay. My first term is 1 and my last term is 100. And then let us work it out. Okay, so I have 100 over 2. I could have just written 50. But anyway, and then we have 101. So the sum of all the natural numbers is 5050. Now, if I look at the sum of all the multiples of 3, okay, so I have, let me just put a line over here. So I have 3, 6, 9, and so forth. And my last term would be 99. Okay, that is also a multiple of 3. All right, so to get to the next term, I need to be adding 3 all the time. So I still have an arithmetic series here. Okay, I've written it as a sequence, but yeah, you get my drift. I should be actually putting plus signs and not semicolons, but it's all good. So now I'm still going to use this formula here because I have my first term and then I have my last term. But now we need to determine how many terms do we have. Okay, so before I even begin there, if I were to get my general term formula, okay, it would be A, which is 3, plus n minus 1, okay, multiplied by the common difference, which is also 3. So if I multiply this out, I would get 3n minus 3 and then plus the 3. So my general term formula is that Tn is equal to 3n. So now if I have there, I want to know, for me to get to 99, how many terms would I need? Okay, so if I divide by 3 both sides, I would get that my n is 33. Okay, so now we can go ahead and use the sum formula. Okay, that line is not so straight. All right, so n would be 33 over 2. My first term is 3. My last term is 99. And then let's work it out. Here's the calculator. Okay, so I have 33. Let me just edit this one. And I have 3 plus 99, which is like what, 102. I'm not risking it. Okay, so I have 1683, 1683. Okay, guys. So I'm not done. They said we should evaluate, right? We should evaluate the following. And I said my strategy is to take the sum of all the natural numbers and subtract the sum of the multiples of 3. So the sum of the natural numbers is 5050. And the sum of the multiples of 3 is 1683. So now my final answer would be 5050 minus the previous answer. So I have 3367. And that wraps up question 1.
Okay, so you're gonna do question 2 with me right now. Let's get right into it. Okay, welcome, by the way. All right, so consider this sequence here. Okay, now whenever they give you a fraction, most of the time you might find that you have 2 different sequences. Okay, like for example, if we look at here, okay, the top part of the fraction is actually, it looks like an arithmetic sequence, but the bottom part of it looks like a geometric part. But let's go ahead and answer the question. Let's see what they want. Question number 1, write down the next 2 terms of the sequence. Okay, question 1. All right, let's just take the top numbers of the fraction. We have 1, 3, 5, 7. Okay, and if just by looking at it I can tell it's an arithmetic, but let's go ahead and solve it. D, if you remember, is term 2 minus term 1. Okay, it's also term 3 minus term 2. So let's go ahead and solve these and see if they give us the same answer. Term 2 is 3 minus 1, which is equals to 2. Term 3 is 5 minus term 2, which is 3, which is still equals to 2. So there we go. This is our D, and this is arithmetic. Okay, now let's look at the bottom numbers. We have 2, 4, 8, 16. Just by looking at it, I can tell that it's a geometric. So under geometric, we saw for R, and it's equals to term 2 divided by term 1. Okay, it's also equals to term 3 divided by term 2. So let's see if they give us the same number. So term 2 is 4 over 2, which gives us 2. Okay, term 3 is 8 over term 2, which is 4, which gives us 2 as well. And this makes a geometric. Okay, now they want the next two terms. The question wants the next two terms. So that means on the top number, which is the last one, is 7. So the next one is 7 plus 2, which gives us 9. And then 9 plus 2, which gives us 9, 10, 11. Okay, now at the bottom with this one, we don't add the ratio, we multiply it. So the next one is 16 times 2, which is 32. And then 32 times 2, the next one will be 64. So these are our next two terms. All right, so we've answered this question. Write down the next two terms of the sequence. Now it says determine the nth term of the sequence. Okay, that's part 2. Let's start with the arithmetic. The arithmetic part of the equation. So that one, it's the term formula is given by a plus n minus 1 d. We've already solved our d. We know our a. Our a, if we just go back, is 1, and our d is 2. So we're going to put 1 there, plus n minus 1, d is 2. Okay, we'll leave this and get rid of the brackets. We'll just multiply the 2 inside here. Okay, so it's going to be 2 times n, which is 2n. 2 times minus 1 is minus 2. And then if I add that, I'll be left with 2n. 1 minus 2 is minus 1. Okay, so we're done with the arithmetic part. That's the equation. Let's do the geometric part now. Geometric. The geometric part, the equation is given by Tn is equals to a times r. Okay, my r, I like to put it in brackets, and minus 1. Okay, so our a is the first number. Okay, if we check it out, it's 2, and our r is also 2. Okay, so we'll have 2 here times 2 to the power n minus 1. Now, I like to simplify this. If you remember the laws of exponents, you can do this. 2 is just 2 to the power 1. Okay, and then we can separate these such that we'll have 2 to the power n times 2 to the power minus 1. Okay, if you remember, if we have the same bases, okay, the bases are 2. Okay, it means we can add the exponents too. So it's 1 plus n minus 1. 1 minus 1 is 0, so we are really just left with 2n. Okay, so for our final, therefore, our final equation, our final Tn is given by the arithmetic part, which we've solved it to be 2n minus 1 divided by the geometric part, which we've solved it to be 2 to the power n. Well, that's it for this question. Let's see what we have for the next one.
Hi guys, welcome to NV Tutors. I'm Tulu and I'll be doing question 3 with you guys. Okay, let's get to it. So it says the first two terms of a geometric sequence and an arithmetic sequence are the same. The first term is 4. Okay, the sum of the first 3 terms of the geometric sequence is equal to 1 more the sum of the first 3 terms of the arithmetic sequence. Determine the possible values of R, the common ratio of the geometric sequence. Okay guys, so they tell us that the first 2 terms, so I'm going to have here geometric, what did I do now? Alright, so geometric and arithmetic. So the first term is 4 for both of them. Okay. The second term is also the same. And then, oh, they said the first 2 terms are the same. So the third one won't be the same. Okay, so I can work with this. So given the info, I can then see here that for the geometric sequence, my common ratio would be x over 4. Okay, I'm only going to look at the first 2 terms because they are equal. Okay, for both the geometric and the arithmetic. And then here, for the arithmetic sequence, I know that my common difference would be x minus 4. Okay, so then I can write down my term formula. Okay, remember for the geometric is a r to the power n minus 1, and then for the arithmetic it is a plus n minus 1 d. Okay, so if we substitute what we know, a would be 4, r would be x over 4, and then we have n minus 1. If we simplify here, we have a as 4, and then n minus 1, and d would be x minus 4. Okay, I think let's just go back to the question and see what they are asking us. I know they want us to determine the value of r. Okay, oh, the sum. So the sum of the first 3 terms of the geometric sequence. Okay, so the sum of the first 3 terms, so if I were to put it, I would say the sum of the first 3 terms, 4 plus x plus y, okay, is equal to 1 more than the sum of the first 3 terms of the arithmetic sequence. Okay, that should be than, not that. 1 more than. Ooh, okay. Yeah, English. All right, so it is equal to 1 more than the sum of the first 3 terms of the arithmetic series. So 4 plus x plus z. Now what I need to do, I'm going to get the 3 terms from the geometric sequence and the 3 terms from the arithmetic sequence, because this is my goal. Okay, once I have this, I can be able to determine r. that they requested. They did request for r, right? Yes, determine the two possible values of r. Okay, so T1, okay, would be, oh, we already know the first term. It's 4. Also the first term here, it is 4. We know the second term is x, okay, because the first two terms are the same. If I were to substitute 2 in there, guys, I would get x, okay? If you don't believe me, you can go try it. T3, okay, I'm going to work it out. So I have 4 x over 4, and then 3 minus 1. Okay, if I simplify it, I have 4 x over 4 squared. So then I have 4 x squared over 16, which is x squared over 4. So that is my third term for the geometric sequence. Okay, the third term for my arithmetic sequence. So I have a as 4, and then I'm looking for the third term. And my difference, let me just check again, it's x minus 4. Okay, so I have 4, 3 minus 1 is 2, so I have that over there, and then, so I have 2x minus 8, then I have 2x minus 4. Okay, now I can use this formula over here. Okay, so I have 4 plus x, and y would be equal to x squared plus 4. So 4 plus x squared over 4 is equal to 4 plus x. Okay, there's a 1 here. 1 plus 4 plus x plus 2x minus 4. And then now we're simplifying. Okay, yeah, what can I cancel? So this 4 and that 4, they cancel, and then these two x's cancel, and then I'm left with, I'm just gonna put everything this side, x squared over 4. I'm gonna take 2x this side, so minus 2x, and then there's a 4. If I take the 1 that side, I'm gonna be left with 3 is equal to 0. Then I'm gonna multiply everything by 4 because I don't want to deal with fractions. Okay, now we can solve for x. Alright, so I have x, and then the factors of 12, 6 and 2 will give me 8. Okay, and if I said, yeah, negative 2, negative 6 will give me negative 8. So yeah, x is equal to 6, or x is equal to 2. We're not done yet though, we need to get r, remember? Okay, so if I use x is equal to 6. Okay, remember my geometric sequence? It was 4 x, x, and the last term was x squared over 4, right? So I figured that x is 6, so I can put it in. 6 squared, it is 36, divided by 4, it is 9. So I see here, from 4 to get to 6, I need to multiply by 1.5, né? That's 3 over 2, right? And again, to get from 6 to 9, I need to multiply by 3 over 2. All right, 6 times 3 is 18, divided by 2 is 9, yes. I almost took out the calculator. So then I know that r is equal to 3 over 2. Or you could say 1.5. Okay, that's the solution for x being 6. The solution for x being 2, what r will it give us? So again, we had 4x and then x squared over 4. So 2, and now 2 squared is 4, divided by 4 is 1. And to get to 2, I had to multiply by a half. And again, to get to 1, I had to multiply by a half. Therefore, r is equal to a half. So there are our two solutions, 3 over 2 and a half. And that sums up the question. We're done with question 3.
All right, you're back here with me. So we're going to do another question. Question 4. It says 20x and y is a geometric sequence and xy 60 is an arithmetic sequence. Determine the values of x and y. So we're going to treat each one accordingly. Let's start with the geometric one. So we know that for geometric we need a common ratio, which is given by term 2 divided by term 1, also given by term 3 divided by term 2. Okay, so term 2 in this case is x over term 1, which is 20, and then term 3 is y over term 2, which is x. Okay, so because these are geometric, they should give us the same answer. So we're just going to combine them then and say x over 20 is equals to y over x, sorry. Okay, and then let's just further create an equation by cross multiplying. I'm going to take this x, bring it to the other side. It makes x squared is equals to the 20 to the other side. It becomes 20y. So this will be our equation number 1. Let's call it equation number 1. For equation number 2, now let's take the arithmetic part. Now the common difference for arithmetic is given by term 2 minus term 1, okay, but also term 3 minus term 2. Okay, let's start with this one. Term 2 is y, and then term 1 is x. So it's y minus x. Term 3, as you can see, is 60. 60 minus term 2, which is y. Now these are arithmetic, so they should also give us the same. Okay, so if you equate them, they should give us the same answer. So we have that is equals to 60 minus y. Okay, let's just combine them and see what we get. I'm going to take this y to the other side, and it changes sign to a positive. So I have 2 y's. I want to take this x to the other side and then take this 60 to the other side. So that the subject of the formula is x. So it's going to be minus 60 because I'm bringing it to this side. It changes sign. And then I take this x to the other side. It becomes positive. Okay. So yeah, this is, I'll call this one equation number 2. Okay, so what I want to do now is take equation 2 and put it into equation 1. So I will say 2 into 1. Okay, this will be given by 1, as you can see, equation number 1 over here is x squared. Where there is an x, we will substitute this x of equation 2, which is, open the brackets, 2y minus 60 squared. Okay, and that will be equals to 20y. Okay, so I hope you understood there. Now, I like, whenever I get a situation like this, this means that I need to multiply this out. I like to create 2 of them, okay, instead of doing it quickly. But if you can do it the short way, go ahead and do it that way. I just prefer this one because it makes sure that I don't make any mistakes, okay, and then I lose nothing. And then on top of that, what I like to do is a little exercise. Let me do it in this blue, where I take this, I just want to draw a line like that, and then there, and then this one there, and then also multiply with that. Okay, now all this means is that I'm gonna say 2y times 2y, which gives me 4y squared, and then 2y times minus 60, I'm gonna get minus 120y, and then here minus 60 times 2y, I get minus 120y, and then finally 60 minus 60 times minus 60, I'll get minus positive 3600 is equals to 20y. All right, now I just want to combine like terms, so I'm going to say 4y squared minus 20 is actually minus 240. Yes, and then if I bring this to the other side, let me not bring it right now, let me just take it one step at a time. I'll have 240y plus 3600 is equals to 20y. Okay, now I can take this 20 to the other side. I'm going to have 4y squared minus 200. If I take this 20 to the other side, it becomes 260y plus 3600 is equals to 0. All right, now I want to divide everything by 4. I'm going to have y squared here minus, I don't know what 260 divided by 4 is, so I'm just going to say, put it in a calculator real quick. It's 260 divided by 4, 65. So I got 65y here. Plus, now I need also 3600 divided by 4. I get 900. This equals to 0. Okay, now I can factorize this. I'm going to open 2 brackets. That'll be equals to 0. Put y on both sides. Now I need a number that when I multiply, it will give me 900, and then when I add them, they give me 65. So let's bring out our calculator once again. Let's say 900 divided by 20 is 45. Okay, so I will take 45 and 20, because 45 times 20 is 900, right? Now for my sign, if I multiply them, they'll give me 900. For the sign, I will get it from this term here. It should be negative. So negative 45 minus 20 will give me negative 65. So that's how I determine my signs over there. From there, I can then conclude that y is equals to 45 and y is equals to 20. Now, let's not lose the question. Okay, the question was asking us to determine the values of x and y. Okay, all we've done right now is determine values of y. We have two values of y. So we need to determine values of x now. We're going to say if y is equals to 45, then x is equals to, let's go and look at equation number 2. You see equation number 2, subject of the formula was x. So we should have 2y minus 60. Okay, 2y minus 60, remember that. So 2y, where there's a y, we'll substitute 45 minus 60. This is actually from equation number 2, just to let you know. And then let's quickly put this in a calculator, shall we? Okay. We have 2 times 45 minus 60. And we got 30. Okay. And then, okay, so we're done. If y is equals to 45, then x is equals to 30. But also, if y is equals to 20, then x is equals to 2 times 20 minus 60. Let's quickly put that in the calculator. We have 2 times 20 minus 60, which gives us minus 20. Okay, so those are our two final answers. You can leave it there. You'll get your full marks. You can just underline to show that you are done. This is where you'll find our answers. Thank you so much.
Alright guys, Figa just did question 4 and I'm doing question 5 right now. Alright, so it says an arithmetic sequence and a geometric sequence are combined to give the following series. Okay, so I have 3, 4, 8, 9, 12, 16, 20, 24, 27, 28, and the last two terms 7, 29, and 7, 32. Okay, so I want to first see what can I recognize here. Is there a pattern that I'm seeing? I do know that one will be an arithmetic sequence and the other will be a geometric sequence, right? So let's see which is which. Okay, so if I look at 3. Alrighty, so I can see 3 here and then 9 is a good fit. If I have 4, 8, so from 3 to 9, I would have to multiply by 3, right? From 4 to 8, I multiply by 2, but I have a 12 here. Okay, so I would say 4, 8, 12. So each time I'm adding 4. So I'm supposing that is my arithmetic sequence. Okay, by 3, 9, 12, no, that wouldn't be arithmetic. It wouldn't be geometric either. But if I go from 3, 9, and then 27, that would be geometric. So yeah, 4, 8, 12, 16, 20, 24, 28, and then lastly 7, 3, 2. So I now can see my geometric sequence, which is 3, 9, 27, and the last value being 7, 2, 9. And then I can see my arithmetic sequence, which is 4, 8, 12, 16, blah, blah, blah. Okay, the first question. State the first 3 terms and the last term of the arithmetic series. So the first 3 terms, 4, 8, oh, they said series. Okay. Okay, but I'm stating the terms, so it's fine. I can use the semicolon. So 4, 8, 12, and then the last term, 7, 3, 2. And then, secondly, they say state the first 3 terms and the last term of the geometric series. So I have 3, 9, 27, and the last term being 7 to 9. Okay. All right, and then the last question, determine the sum of the combined series. Okay, you know what, because they said series, let me go ahead and put addition. Okay, so 4 plus 8 plus 12 and 3 plus 9 plus 27. Okay, determine the sum of the combined series. All right, so yeah, I will be determining the arithmetic first, okay, and then I'll go over to the geometric. So yeah, I have my first term and my last term, so we know which equation we're going to use. Okay, and because it's going in multiples of 4, starting with 4, our general term equation is just going to be 4n. All right, so if I'm looking for the number of terms, I know my last term is 732. So if I want to know how many terms are there, if my last term is 732, I can work it out this way. So let's just pop up the calculator and say 732 divided by 4. We have 183. 183 terms. Okay, so 183 over 2. The first term is 4. The last term is 732. And the sum thereof, therefore, is, okay, 183 over 2. 4 plus 732. It is 67,344. Okay, now let's have a look at the geometric. Okay, the geometric formula. Just need to make sure I'm writing the correct things. 1 minus r to the power n. And it's 1 minus r. Okay, am I correct or am I just telling lies? Yes, it's all good. All right, so the first term is 3, right? Yes, the first term is 3 and 1 minus. So r is also 3. Now getting the number of terms. So your general term formula, that is ARN minus 1. So the first term is 3. The difference or the common ratio is 3 n minus 1. And I'm looking for, yeah, last term there being 729. Okay. If I divide 729 by 3, what do I get? I get 243. Okay, so I have 243 is equal to 3 to the power n minus 1. Okay, so At this point, I could use logs to get what n minus 1 is and ultimately n, but you haven't covered that yet. So 2, 4, 3, let me just check. If I say 3 to the power 3, what is that? That's 27, right? So if I say 3 to the power 4, that's 81. 3 to the power 5, 2, 4, 3. Okay, so 3 to the power 5 is 2, 4, 3. So I can make the exponents equal. So now n is equal to 6. So where were we? Yes, 6. And I have 1 minus 3. So I'm just going to plug all of that in the calculator. So we have 3, 1 minus 3 to the power 6. And then you have negative 2 at the bottom. So ultimately my answer is 1092. Yeah, but they wanted the sum of the whole series, the combined series. So we're not done. So ultimately the sum of the combined series would be 1092 from the geometric series and 67344 from the arithmetic series. And ultimately I have 1092 plus 67344, and our answer is 68,436. And that concludes this question.
Okay, back here with me again. We're doing question 6 now. So check this out. Determine the value of A if A is given in this sigma notation. I hope you took your lesson on sigma notation. It's under arithmetic sequence lesson if you are interested. But let's just get it over and done with. The first thing you have to do here is to determine your terms. So we need term 1. To calculate term 1, we will use this equation. Okay, we'll use 5k minus 6. Excuse me. But for k, it's gonna be 1. Okay, because it's k there and it's term 1, so we just go ahead and substitute 1 there, minus 6, which will give us 5. 1 minus 6 is minus 5. That's it. And then we need term 2. Gonna be 5. We put 2 instead of k, minus 6, and then we get 5 to the power 2 minus 6 is minus 4. And then we need a third one just for confirmation. 5, 3 minus 6, which gives us 5 to the power minus 3. Okay, we got 3 terms now. Okay, next thing to do is actually to get the r value, because we can see from the formula that this is a geometric sequence or a geometric series, because we're dealing with the sum. Sigma notation gives us the sum. Okay, means the sum. So let's get the common ratio. The common ratio, remember, is given by term 2 divided by term 1, which is also given by term 3 divided by term 2, just for confirmation. Okay, so let's start. Term 2 is 5 to the power minus 4 divided by term 1 is 5 to the power minus 5 as solved. We can put that quickly in a calculator. Okay, so let's just do that quickly. There, 5 to the power of minus 4. Okay, and then here we have 5 to the power of minus 5. And we get the answer is 5, just simply 5. Okay, term 3 is 5 minus 3 over term 2, which is 5 minus 4. You could do this also using the, if you don't want to use the calculator, you can use the rules of exponents. Okay, where it's minus 3. Anything at the bottom, it's minus 4. Okay, which gives us 5 as to the power 1. Okay, because 3 minus 4 it gives you 1. Those are just rules of exponents, but you can put it in your calculator since you're allowed to bring it in the exam room for these type of questions. Okay, we have R. Now we need to solve A. We've solved A already. The first term, which is 5 to the power minus 5. We also need to solve N. Okay, so for N, we always say the top minus the bottom plus an extra 1. Okay, so the top is 15 minus the bottom, which is 1, and then we always add 1. Okay, so this gives us 15. If, for example, our sigma notation, this is just an arbitrary example, so let me change the color, maybe make it blue. If a sigma notation was like this, k is equals to 3 and there's 15 here, then to solve our n, we would say 15 minus 3 and then plus 1, an extra 1, which will give us our n would be 15 minus 3 is 12, plus 1 is 13. So our n would be 13 in this case. Okay, this is just an arbitrary example. Okay, but let's continue with our question. It's 15. We need the formula now for the sum. And it's actually given by A, and then you open the brackets and then you put 1 minus Rn divided by 1 minus R. Okay, let's just get the equation right for now, or we can just put everything together. Okay, so we can say S to our Sn, then therefore, or rather, remember our n, we solved it to be 13. Okay, and then our A is 5 to the power minus 5. We have 1 minus R. We solved R to be, remember we solved R here, we solved it to be 5. So our R is 5, our N is 13, close the brackets, divided by 1 minus our R is 5. Okay, so now we can just simply put this in a calculator. We have 5 to the power minus 5, okay, and then we have, open the bracket, 1 minus 5 to the power 13, okay, and then we can close the bracket, and then we come down, there we have 1 minus 5. Something is amiss here, something is not right. Okay, oh sorry, my bad, we are solving the wrong we are actually solving for the example of 13. You see, making examples can confuse me too. The actual one, it should be n is 15. Okay, so here instead of 13, we should have 15. Okay, so it's okay to make mistakes. The thing is to go back and correct them. That's why I'm not gonna edit this. I'm just gonna put in the right number. Okay, so there, delete all of this. What's going on here? Let's delete this. So there we have minus 5 to the power 15. There we go. So that's our final answer. That's our final answer. It's 2441406.2. If I'm doing 2 decimals, then that 4 becomes a 5. Okay, so also here, let's rub this. This should be 15. Okay, and so that is how you evaluate your sigma notation questions. That's how you do them. Thank you very much.
Welcome back, guys. I'm Tsulu and I'll be doing question 7 with you. So yeah, what does it say? A quadratic pattern has a third term equal to 16, a fourth term equal to 35, and a sixth term equal to 91. Okay. The first question, determine the second difference of this quadratic pattern. We aren't given much here, are we? But let's see what we can do with what we have. So if they're asking for the second difference, remember with the quadratic pattern, you have your pattern, and then you have the first difference, and then the second difference. And the second difference is the same. It's basically equal. Okay. If you remember the diagram, it is actually 2a. Okay, this is the diagram I'm talking about. So we know that our general term formula is an squared plus bn plus c. So if I have n equal to 1, okay, I would have a plus b plus c. If I have n equal to 2, I would have 4a, meaning I substitute 2 in there. So 2 squared is 4. So I have 4a, 2b plus c. If I have n is equal to 3, I would have 9a plus 3b plus c. And if I have n equal to 4, I would have 16a plus 4b plus c. Okay, so that is the first row. And then to get my first difference, I would subtract the second, the second term here minus the first term. So 4a minus a, I would have 3a. And then 2b minus b, I would have b. And then the c's cancel. Okay, then I have 5a plus b. And then I have 7a plus b. And then finally, the second difference, the reason why we say the second difference is the same is because 5a minus 3a is 2a. The b's cancel. 7a minus 5a, still 2a. Okay. So yeah, they are looking, if the first question says, determine the second difference of this quadratic pattern, they are looking for basically what is 2a equal to. But yeah, guys, what do we have here? They told us that the third term is 16. So T3 is 16. The fourth term is 35. And then the sixth term is 91. All right. Yeah, let's see. So I'm gonna start with T3. Okay. So I have 16. Then I have 35. Okay, so this is T3. That's T4. And then T5, well, that is unknown, so I'm just going to put X. T6, we have it, it's 91. I think I'm just going to put T7 for control. I don't know if we're going to need it, but yeah. So I would say that would be Y because we don't know what T7 is. Okay, so if I go and do my first difference, I get here that T4 is 35 minus 16. What is that? 35 minus 16, that's 19. Okay. Should you have a T2? I don't know, maybe not. Okay. And then that would be X minus 35. Okay. That would be 91 minus X. And that would be Y minus 91. Okay, are we getting somewhere here? Let's do the second difference. Let's see what we're gonna get. So I have X minus 35 minus 19. Okay, just gonna put that in brackets. And then here we have 91 minus X plus 35, because it'll be minus 35. I hope you guys are following. Okay, and then the last second difference, I have Y minus 91 minus 91 plus X. Okay. All right. And then guys, once you get here, remember the second difference is the same. Okay. I can equate these ones. So I'm going to equate those with only one variable. Okay, one unknown. And I'm not going to equate these two because I have X and I have Y. And I need two equations to solve for two unknowns. So I'm going to go for these ones. Okay, I can use these ones, this term and that term, and equate it to each other. Okay, like we did here. We know that the last or the second difference is equal. Okay, for the quadratic pattern. So I have, okay, firstly, what is negative 35, negative 19? Let's just get that out of the way. Negative 19 minus 35, that's negative 54. So I have X minus 54 is equal to, what do I have here? 91 plus 35. What is 91 plus 35? That's 126. So 126 minus 2x. All right. Can we do something here? I believe so. So if I take x that side, I would have 3x. And if I say 126 plus 54, I have 180. Oh, nice. It's a nice term. So x would be 180 divided by 3, which is 60. Okay, we're getting somewhere here. So we know that the fifth term is 60. Okay, but yeah, guys, I still haven't determined what 2a is. Okay, so I can just say 2a is equal to x minus 54. And we know x is 60. So 60 minus 54 is 6. Okay, so we've answered the first question. Okay, the second question says determine the first term of the pattern. Okay, so this was the first question. Now the second question, they want the first term of the pattern. Okay guys, I'm going to write this pattern again. Okay, so I have 16, 35, and now 60, and then the last term was 90, 91, right? Yeah, 91. That was, okay, so that's term 3, term 4, term 5, term 6. Let me just put it there. Term 3, term 4, term 5, term 6. Now we can do something. Okay, so the difference between those two, I think it was 19. And the difference between these two should be 25. Difference between those two should be 31. Right. And now I need 6 to get to 25, and I also need 6 to get to 31. Oh yeah, we did determine that TA is equal to 6. But yeah, so now I need to get the first term, so I pretty much have to get the second term as well. Okay, so to get this one, I need to say 19 minus 6. I'm gonna get 13, right? Because to go from 13 to 19, I need 6. Then I'm gonna say 16 minus 13, that is 3. That's my second term. And to get my first term, 13 minus 6 is 7, right? Yes, because to get to 13, I need to add 6 to 7. And then 3 minus 7 is minus 4. Okay, and that is my first term. Okay, so you can write it out nicely. T1 is equal to negative 4. Now the last question. Determine the nth term of the pattern. Okay, so the nth term of the pattern, I need to know what A, B, and C is. Okay, so just looking at this over here. All right, I am going to equate it to that over there. Okay, so 2A would be equal to 6. So I have that A is 3. And then 3A plus B equated to 7. So we know that A is 3, so 9 plus B is 7, so B is equal to negative 2. And then lastly, A plus B plus C is equal to negative 4, because that is the first term. A is 3, B is negative 2. Okay, so 3 minus 2, that's 1. If I take it that side, it will become negative 1 plus negative 4, that is negative 5. Okay, so I have my A, B, and C. Now I can write down the nth term formula. So the nth term formula would be 3n squared, minus 2n minus 5. And when you get here, guys, you don't rejoice and think you're done. You better test it. Okay, so let's test it for T 6, which should give us 91. And let's test it also for T3, which should be 16. Okay, and even maybe T1. Let's see if we're going to get that negative 4. Okay, so I have 3n squared minus 2n minus 5. Okay, yes, T6 is 91. If I put in a 3 there, what do I get? 16. Yay, and if I put 1, minus 4. So yeah, guys, our formula works, and this concludes this question.
Well, let's get into question number 8 now. Okay. Now, it says the following sequence forms a convergent geometric sequence. Now, what do we know about convergent? We know that a sequence is convergent if the common ratio is between 1 and -1. Okay, then we know that something is convergent. Okay, so that's the series that's convergent. It means it has a definite solution if you add up all of these to the infinity. Okay, so there it is. Number 1, determine the possible values of x. Okay, now we know that common ratio is given by term 2 over term 1. Also, just to confirm, term 3 over term 2. Okay, I like doing both. Let's start with this one. Term 2 is x squared over term 1 is 7x. This is equals to, so that x cancels that one, and then we're left with x over 7. Here, term 3 is x, okay, over 7, and then term 2 is x squared. Okay, whenever I have this kind of situation over here, I like to just divide this one by 1. Okay, so that I have 4 things. Once I have 4 of them, 4 terms, I can put the first and second exactly as it is. And when I multiply, then I have to take the reciprocal of this one, which would be 1 over x squared. Okay, so 2x's cancel that, and I'm left with x over 7. Okay, so that's our R. They want the possible values of x. Now, we're gonna go back to our convergent and condition, and where there's R, we just solved R to be x over 7. Okay, so minus 1. So if you get rid of this 7, you'll be left with x. If it comes this side, it just becomes 7. If it comes this side, it's minus 7. Multiply this side. Okay, so that answers our question. Determine possible values of x. So x can be any number between minus 7 and 7. Now, if x is minus 4, calculate s to infinity. Okay, so that just means the sum of the infinite numbers. So let's start with the equation. It's equals to a over 1 minus r. Okay, I think that's the one, if I'm not mistaken. All right, so we need a and we need r. Okay, so how are we going to get a? Term 1. We are told if x is equals to minus 4, and term 1 is 7 times minus 4, because that's x. So a is 7 times minus 4. I should be knowing that by head, but I don't. It's minus 28. Okay, the other thing that we need is r. Okay, and r, we already have r, that is x over 7. And remember, x this time is minus 4 over 7. Okay, we have a and we have r. We can go ahead and substitute there. Sum infinity. A is minus 28 over 1 minus 4/7. Let's put that in the calculator real quick. Okay, we've got a fraction there, minus 28. Let's go down. We got 1 minus we have another fraction there, which is minus 4/7. Okay, so that gives us, it's equals to minus 196 divided by 11. All right, so that is our final answer. Thank you so much. Hope you understood.
Hi guys, I'll be doing the last question with you, question 9. Alright, so it starts by saying the first term of an arithmetic sequence is 1. The first, second, and fifth terms of the arithmetic sequence form a geometric sequence. And then they say the common difference is not 0. So the first question, find the common difference of the arithmetic sequence. And then second question, determine the first 3 terms of the geometric sequence. Okay guys, we're not really given much info here. We only have 1. But anyway, let's write the first 5 terms. Okay, so for this arithmetic sequence, okay, I have the first term as 1, then I have the second term. Okay, let me do this rather. Okay, I have the first term, second term, third term, fourth term, and fifth term. Okay, what can we do with this information? All right, so they tell us that the first, second, and fifth terms form the geometric sequence. Okay, so the first, second, and fifth terms form the geometric sequence. Geometric, oh gosh, can't spell. Geometric. Okay, so I have 1 first term, W second term, and Z as my third term. Okay, so what can I do then with this info? What I can do, I'm going to start with the geometric. I want to get what the common ratio is. So I have that the common ratio, remember common ratio is T2 over T1 is equal to T3 over T2. So T2 is W over 1, which is equal to Z over W. And I can simplify it to say that W squared is equal to Z. But what will that do for me? Okay, so I can write Z in terms of W. And then let's see what happens. I'm going to go back to my arithmetic series. Okay, so I have my first term as 1, my second term W, X, Y, and Z. We know that Z is W. Okay, what are we looking for again? The common difference in the arithmetic series or sequence. Okay, so we know that to get the common difference, that will be W minus 1. That will be X minus W. That will be Y minus X. And that will be W squared minus Y. Okay, and we know that the common difference is the same, right? So we can equate basically all of this. So I'm going to start on the far left. So I have W minus 1 is equal to X minus W. So x is equal to 2w minus 1. Okay, then I'm gonna go over to this in the middle here. Okay, so I know that y minus x is equal to x minus w. Guys, we're just doing things and hoping for the best. Okay, so if I were to take, let's see, I would say y is equal to 2x minus w. Okay, so do you see I already have what x is? Okay, so I'm going to write y in terms of w by substituting the value of x. So then y is equal to 2 times 2w minus 1 minus w. So then I have 4w minus 2 minus w. It will be 3w minus 2. So I have y in terms of w. Then I can do the last, equate the last. So I started with this, then the middle, and then now the last. So I have y minus x, just write it here, y minus x is equal to w squared minus y. Okay guys, this is great. You know why? I have x in terms of w and I have y in terms of w, so my only unknown will be w, which is what we want. One equation, one unknown. Alright, so we said that x, actually let me just simplify it first before I go far. So w squared is equal to 2y minus x. I have y as 3w minus 2 and I have x as 2w minus 1. Okay, we're getting somewhere here. Okay, let us simplify it. So we have 6w minus 4 minus 2w plus 1. Now, I'm going to, let me simplify it further. 6 minus 2, that is 4w, minus 4 plus 1, that is minus 3. So taking everything to the left-hand side, I have w squared minus 4w plus 3 is equal to 0. Okay, so we have w, 3, 1, negative, negative, yeah. So w is equal to 3 or w is equal to 1. Okay guys, let me remind you of the arithmetic sequence we had. We had 1, then w, then x, then y, then z, which was w squared, but I'm just going to put here. They told us in the question that we should look for the first difference, but they specifically said this difference, or not even the first difference, the common difference, and they specifically said the common difference cannot be 0. Okay, let's go back if you forgot. So it says the common difference is not 0. So if we were to use w is equal to 1, do you realize that we would have a difference of 0? So in that case, w cannot be equal to 1, but w would be 3. Okay, so then we have 1, 3. Okay, we had x in terms of w. Did we not? Yes, we did. So if w is equal to 3, we have 2 times 3, which is 6 minus 1, that is 5. Okay, y, I believe we had it in terms of w, there it is. So 3 times 3, that is 9, minus 2, that is 7. Okay, and then z, it was w squared, so that is 9, 3 squared. So there we have our arithmetic sequence. And the question again, find the common difference. Okay, so we know that d is equal to 2, we'll go back down. And then it says find the first 3 terms of the geometric sequence. So question number 1, d is equal to 2, because you can see we jump in 2's. That makes sense. Okay, and then the first 3 terms of the geometric sequence, remember, the first term, the second term, and the fifth term form part of the geometric sequence. So we have 1, 3, and 9. And if you look there, your r, they didn't ask for it, but r would be 3. Okay, the common ratio would be 3. And that concludes this session. Thank you guys. If you need a tutorial session, please do visit our website, make a booking, and then we'll be happy to assist you. All right, please don't forget to like our channel or this video and subscribe to our channel. Bye. Hi guys, so I decided to do a bonus question just to see in real life what kind of questions could they ask and where to apply the series and sequence topic. Okay, let's get to it. A shrub grew in a tree house, no, in a greenhouse for 1 year and reached a height of 108 centimeters. The shrub was planted in a garden and in the second year grew 54 centimeters. Okay, so it grew by 54 centimeters. During each consecutive year, the height increased by a third of the previous year's increase. Okay, so here you need to know English. It says calculate the height of the shrub after 5 years, and B, show that the shrub could never reach 2 meters. Okay, that is 200 centimeters. So yeah, what happened? So in year 1, okay, in year 1, it was 108 centimeters. In year 2, it increased by 54 centimeters. So that 108 plus 54, okay, that would give you 162. All right. And now what happened in year 3, what happened in year 4, and what basically A is asking is what is happening in year 5. So we need to figure out here what is happening, because they say during each consecutive year the height increased by a third of the previous year's increase. Okay, so here it increased, okay, it increased by 54 centimeters. Okay, so now we need to ask ourselves, to get to the third year, okay, to get to the next year, so each consecutive year, the height increased by a third of the previous year's increase. So the previous year, it increased by 54 centimeters. So now I need to know what a third of 54 is. Okay, so a third of 54, that is 18. Okay, so 18 centimeters. So from year 1 to 2, it grew by 54 centimeters. So therefore, its height was, okay, let me just say this is the height. And this is the, what do we call it? The growth. Okay, so it grew by 54 centimeters and reached a height of 162. Here it grew by 18 centimeters. So I need to add 18 to that 162. Okay. And I get 180. Oh, why am I writing degrees? I'm thinking 180 degrees. My goodness. Okay, so it reached 180 centimeters. Now to get to year 4. So in year 3, it grew by 18 centimeters. So I need to take a third of that 18 centimeters. Okay. And then what will I get? I'll get 6 centimeters. Okay. So then I need to add the 6 centimeters to the 180. So I have 186 centimeters in year 4. And again, to get to year 5, I need to take a third of that growth. Okay, which is 2 centimeters. So we can see its growth reduces over time. Obviously, they said by a third. Okay, so yeah, it's not growing as much. And clearly, when we look at B, it will reach a maximum height, and that is it. And it can't grow anymore, which sucks. Kind of reminds me of my hair sometimes. It's like it's stuck. So 186 plus 2, that is 188 centimeters. So we have answered A. Okay, so calculate the height of the shrub after 5 years. All right, it is 188 centimeters, or you could say 1,88 meters. Okay, now B, show that the shrub could never reach 2 meters. Okay, so at first, so if you were to look again at this trend, if you look at the height, it's neither geometric, it's neither arithmetic. That's not the sequence that you're looking at. The sequence that you really have is the growth. Okay, so we're gonna look at growth. Okay, not necessarily height. Okay, and then we'll get somewhere with it. So we had 54 and 18, 6, 2. Okay, and you realize here, so to get from 54 to 18, we had to multiply by a third or divide by 3. So then we can see third, same thing here, multiply by a third, and the same thing here, multiply by a third. Therefore, we can see that R is 1/3. Guys, I hope you realize that we have a converging series, okay, or sequence. We have a converging sequence, okay, and and we can see here, if they say it will never reach 2 meters, it means its maximum height. Like, you can calculate as many times as you want and go on with this trend, but you will never reach 2 meters. Therefore, how can we check? You can use your sum to infinity, because we want to know, once it reaches infinity, can you ever really reach infinity though? But at infinity, what will we have? Okay, so, and the formula for that is 1 minus r. But before you even use this formula, you need to check. There's a condition for r. Remember, r has to either be bigger than 1 or bigger than -1 or smaller than 1. It has to be in between -1 and 1, but it can't be equal to it. And we see that we have a third here. So this qualifies. Okay, we can use it. It is applicable. So our first term, there it is. That's A, right? So that's 54. And we have 1 minus r being a third. Okay. And then our answer then, if we say 54, 1 minus a third, that is 81. Okay, but remember, we're looking at the growth. Okay, so 81 centimeters is the maximum growth. Okay, this tree can only grow 81 centimeters. So maximum growth or increase. Okay. So now, where did we start off? Initially, our tree height was 108 centimeters. So now looking at the tree height, we started at 108 centimeters plus 81. This answer better be smaller than 200 centimeters, or else we're in trouble. We didn't prove nothing. Okay, so we see here that the maximum height, so maximum, actually, this should be maximum. Okay, maximum tree height is actually 189 centimeters, or you would say 1,89 meters, which is definitely smaller than 2 meters. It cannot grow further than 1.89 meters. Okay, I hope you enjoyed this question. And yeah, if you have many more, please do contact us, make a booking for a session, and we'll definitely help you. Don't forget to like this video and subscribe to our channel. Bye.